Hello students, in the previous lecture we had a discussion about calculating n factor values for intermolecular redox reaction. In this lecture we will discuss about calculating n factor values for intramolecular redox reaction. Intramolecular redox reaction is a reaction in which in a given reactant one element undergoes oxidation and another element undergoes reduction reaction. Keep in mind, one element undergoes oxidation and another element undergoes reduction reaction. Let me take one example on the board. Let's say we have one redox reaction, it is Fe and we have NO3, and so we have 2 and then we have it is Fe 3 plus and then we have it is NO. Okay, this is a redox reaction. Okay, to identify whether it is intermolecular redox reaction or intramolecular redox reaction, we write down the oxidation number of elements. Okay, so keep in mind, you can see there is one iron is there, as a we have a number 2, we can crisscross the number 2, find out the charge. Okay, so 2 will go on the left side, then we have 2, first one is positive, one will go on the other side, then we have it is negative. First one is positive, second one is the negative. Okay, so Fe has +2 charge and NO3, this is the polyatomic ion, this is nitrate ion, and this nitrate ion has -1 charge. Okay, has -1 charge. Other side it is the monoatomic ion. The charge of a monoatomic ion is equal to its oxidation numbers. Then we have NO, oxygen is -2, then nitrogen will be obviously +2 is there. Very simple concept is there. Okay, now pay attention very carefully. We have Fe. Fe is present in +2 oxidation numbers on the left side and Fe is present in +3 oxidation number on the right side. Okay, we can compare the oxidation numbers. +2 to +3, +2 to +3, increase in oxidation numbers. In the previous lecture we have learned increase in oxidation number is always oxidation reaction. Let me write it. If there is an increase in oxidation number, reaction will always be oxidation reaction, and in oxidation reaction there is always loss of electron. Then we have loss of electron. Okay, now we can compare the oxidation number of nitrogen. This is the polyatomic and its charge is given here. We can calculate the oxidation number of nitrogen in polyatomic ion. We have the polyatomic ion, that is the nitrate ion. Okay, the overall charge is what? -1 is equal to -1. Nitrogen is there. There are 3 oxygen. Each oxygen is what? -2. We can simplify nitrogen. 3 2 is 6, -6 -1 is there. Nitrogen is equal to -1 plus 6 is equal to +5. You can see in this nitrate ion, nitrogen is present in +5 oxidation numbers. Okay, very simple concept. Okay, other side you can see nitrogen is present in +2 oxidation numbers. We can compare +5 to +2, decrease in oxidation number, and decrease in oxidation number is always reduction reaction, and a reduction reaction always gain of electron is there. Gain of electron, very simple concept is there. So you can see Fe2 plus undergoes oxidation because increase in oxidation numbers, and this nitrate ion undergoes reduction because there is a decrease in oxidation numbers. So you can see in a given same reactant, in the same reactant, one element undergoes oxidation and another element undergoes reduction reaction. Then we can say it is an example of intramolecular redox reaction. Intramolecular redox reaction is a reaction in which in a given reactant one element undergoes oxidation and another element undergoes reduction reaction. In case if I have to calculate n factor values for intramolecular redox reaction, keep in mind in the previous lecture we have discussed we calculate n factor values to determine the equivalent weight of a substance. Okay, equivalent weight of a substance. Okay, so for this kind of redox reaction, in case if we have to calculate n factor values, how we can calculate it? Keep in mind the formula is that we have n factor value is equal to n2 minus n1. Okay, n2 minus n1, in which n2 value is always greater than n1. Okay, remember this condition, where n2 value is always greater than n1, so that we can get n factor value positive, because n factor value can never be negative. Okay, it can never be the condition n2 value is less than n1, otherwise we will get n factor value negative, and n factor value negative is not possible. N factor value cannot be 0 also. cannot be 0 also, keep in mind. Okay, so N1 N2 we have the transfer of electron. Okay, these are the transfer of electrons. Okay, maybe loss of electron or gain of electrons. So whatever the value which is larger, then we can take it as N2, the smaller value which we can take it as N1. Okay, now find out the difference in oxidation numbers. Okay, we find out how many electrons are lost, how many electrons are gained. Okay, and so to get this detail, easily we find out the difference in oxidation number of the same element in the reaction. Now focus here. Fe is present in +2 oxidation number, other side iron is present in +3 oxidation number. Find the difference. Difference will be, I always say, subtract a small value from the large value. Okay, so we have the small value and this is the large value. 3 minus 2 is equal to 1. Here we got 1 electron. Okay, difference in oxidation number is what? 1. This is oxidation reaction. In oxidation always loss of electron is taking place. It means like there is one loss of electron. Okay, now I come to nitrogen. Now keep in mind, whenever we try to calculate the difference in oxidation number, you balance the charge. Okay, balance the charge. We always balance the number of atoms. Okay, keep in mind there are 2 nitrogen, whole power 2 is there. There are 2 nitrogen. There are 2 nitrogen on the left side. Okay, other side we have only 1 nitrogen. So I can balance the number of nitrogen. Okay, we are not going to focus on oxygen because oxygen is also -2, other side oxygen is also -2. The oxidation number of oxygen is same, that's why it neither undergoes oxidation nor reduction. Okay, so now you can see 1 nitrogen is +5, then 2 nitrogen, there are 2 nitrogen multiplied by 2 is equal to +10 oxidation number. Very simple concept. Okay, other side 1 nitrogen is +2, then 2 nitrogen multiplied by 2 is equal to, we have +4 oxidation numbers. Simple, right? Okay, we got +4 oxidation numbers. Now we find the difference in oxidation numbers. On the left side we have 10 oxidation numbers, on the other side we have 4 oxidation number. 10 to 4 decrease in oxidation number. What is reduction reaction? What is the difference in oxidation number? 10 minus 4. Even if 4 is given this side and 10 is given other side, you cannot say 4 minus 10 because we will get negative value. A negative value, no, difference in oxidation number should always be positive. Okay, so 10 minus 4 is equal to, we got 6 electron. Since it is a reduction reaction, gain of electron is 6. Okay, as I said, when we try to level N1 and N2, so N2 value is always larger value. You can see in compare 6 value is the larger value than first one, then we can say it is N2, and then we have it is N1. A smaller value will be N1. Now you can apply the formula. N factor is equal to N2 minus N1. N2 value is 6, N1 is equal to 1, and then we can get 5. N factor value for this substance is what? 5. Very simple concept. We got 5. Okay, so formula is very simple. You can just take it N2, the larger value, and the smaller value will be N1, and find the difference. Okay, we simply find the difference between loss of electron and gain of electron. Okay, because this is what? Loss of electron, this is what? Gain of electron. We are finding the difference between loss of electron as well as gain of electron, but in this case we always subtract a small value from the large value. Okay, so the concept is very simple. You can see easily we can calculate and factor values for the intramolecular redox reaction. Let me take some more examples. The next equation is given, the PCl5, it undergoes decomposition reaction, okay, and produces PCl3 and Cl2. In general, intramolecular redox reactions are decomposition by nature. They decompose, and large molecule will split into small molecules. You can see PCl5 is here, it undergoes decomposition and split into small molecules. Okay, so now we write down the oxidation number to calculate and factor values. Okay, so you can see PCl5 is there, Cl is what? -1, halogen is -1. Okay, so 5 multiplied by -1, total negative charge will be what? -5. Then over the phosphorus, total positive charge will be +5. Very simple. Otherwise you can calculate also P and plus, there are 5 Cl, each Cl is what? -1, and it is a neutral molecule, is equal to 0. Then we get P minus 5 is equal to 0, then P is equal to +5. Okay, So as you keep on learning, this kind of concept, so by looking at the compound itself, you can find the oxidation numbers. Okay, you don't need to do the calculation. This kind of calculation is done in the initial stage. Okay, now pay attention to the second substance. You can see Cl3, Cl is -1. Okay, 3 multiplied by -1, total negative charge is what? -3. Then total positive charge will be +3. Phosphorus will have +3 charge. Okay. Other side we have neutral molecule. It has 0 oxidation numbers. Okay, now we compare the oxidation numbers. Phosphorus to phosphorus, +5 to +3, +5 to +3, decrease in oxidation number, and decrease in oxidation number is always reduction reaction. In reduction reaction, always a gain of electron is taking place. Okay, difference in oxidation number also we can find. 5 minus 3 is equal to 2 electron. 2 electron, we got it. Okay, now we come to chlorine. Chlorine to chlorine. Okay, you can see chlorine is -1 on the left side, other side it is 0. -1 to 0, increase in oxidation number, and increase in oxidation number is always oxidation. We have oxidation. In oxidation, always loss of electron is there. Okay, now we can find the difference in oxidation number. Before we find the difference in oxidation number, we always balance the number of atoms. Okay, keep in mind, if we talk about the Cl, how many Cl are there? There are 5 Cl. Okay, if 1 Cl is -1, then 5 Cl will be multiplied by 5 is equal to minus, better I write it here, -5. -5 is there. Okay, very simple. So since we are going to calculate and factor values for a substance in which there are 5 Cl, so other side also you need to get the oxidation number for the 5 Cl. If I multiply this molecule by 5 by 2, so 5 by 2, Cl2 is equal to 5 Cl only, because 2 will cancel, then we get 5 Cl. Okay, and if you take 5 multiplied by 0, you will get what? 0. Same thing. Now find the difference in oxidation number. Left side we have -5, other side we have 0. Okay, so 0 minus -5, you cannot say -5 minus 0 is equal to, then you will get -5, and factor value your difference in oxidation number should always be positive. That's why this is the larger value, this is the smaller value. 0 minus we have 0 minus -5 is equal to what? We get +5. We have 5 electrons. Since it is oxidation reaction, in oxidation reaction loss of electron is there. Now we calculate and factor value for the substance, for the reactant. You can see in the same reactant, this is the only reactant given in the reaction, and it undergoes decomposition. One element, phosphorus, undergoes reduction reaction, and Cl undergoes oxidation reaction. One element undergoes oxidation, another element undergoes reduction reaction in the same given reactant. Okay, and factor value formula is what? And factor formula is, we have N2 minus N1, where N2 is always greater than N1. Okay, we have two values. One value is 5 electron, another value is 2 electrons. So larger value is always N2 and smaller value is always N1. That's it. Find the difference. We have N2 is what? 5 minus N1 is what? 2. Then we got what? 3. And factor value will be 3. Very simple concept is there. Okay, just follow the concept, just to follow the concept. Whenever you have to calculate the and factor values, first you write down the oxidation number, find the difference in oxidation number in both oxidation as well as reduction reaction, then apply the formula. Okay, now after this I take some redox reaction. What kind of redox reaction? Intramolecular redox reaction, in which same number of electrons are lost and same number of electrons are gained also. Okay, means these values are same only. These values means if in the oxidation reaction 5 electrons are lost, then 5 electrons will be gained also, and so it will be intramolecular redox reaction. In this case, how we can calculate and factor values? Let me take more examples. The next redox reaction is given on the board. First we write down the oxidation number of element. Potassium is a first group elements. First group elements present in any compound always shows +1 oxidation number. Oxygen in form of oxide shows -2 oxidation number. We can calculate the oxidation number of Cl. Okay, it is a neutral compound, then is equal to 0. Potassium is what? +1. Cl, for which we have to calculate oxidation number 3. Oxygen, each oxygen is what? -2. plus 1 Cl 3 to just 6, we got it. Then Cl minus 5 is equal to 0, and then we get Cl is equal to what? Plus 5. Cl is present in plus 5 oxidation number. Okay, it is present in plus 5 oxidation number. Other side, potassium is plus 1, then Cl will be obviously in minus 1, and it is a neutral molecule, then it has 0 oxidation numbers. Now we can compare the oxidation number of same element on both sides. Potassium on both sides, same oxidation numbers. Okay, no effect. If I move from Cl to Cl, you can see Cl is present in plus 5 oxidation number on the left side, on the other side it is present in minus 1 oxidation numbers. On the other side, plus 5 to minus 1, decrease in oxidation numbers. Plus 5 to minus 1, decrease in oxidation numbers. Okay, and decrease in oxidation number is always reduction reaction, in which always gain of electron is there. So you can see it is reduction reaction. There is only one Cl. Now we can find the difference in oxidation number. Keep in mind, you cannot say 5 minus 1. Okay, if you write 5 minus 1 means you are adding both. You are adding. We are not getting the difference. You need to differentiate both values. We have plus 5 is there and minus 1 is there. Difference will be what? In these two values, write minus. Okay, many times students will write plus 5 minus 1 is equal to 4. No, that is not correct. Now if you simplify, you will get plus 5 plus 1 is equal to plus 6. Difference is what? 6 electrons. 6 electrons are gained since it is a reduction reaction. Now we can compare the oxidation numbers of oxygen. Left side oxygen is what? Minus 2. Other side oxygen is what? 0. Minus 2 to 0, increase in oxidation number. Increase in oxidation number is what? Oxidation, in which loss of electron is taking place. How many electrons are lost? Okay, it is oxidation reaction, no doubt about it. Okay, now you see how many oxygen are given there on the left side. There are 3 oxygen. One oxygen is minus 2, then 3 oxygen multiplied by 3 is equal to minus 6. Okay, other side also you need to calculate the oxidation number of 3 oxygen. If I multiply it by 3 by 2, so 2 will cancel, we got 3 oxygen, and so multiplied by 3 we get 0. Okay, minus 6 and 0, difference between minus 6 and 0 minus 6, because 0 is the large number. So 0 minus 6 is equal to 6. We got 6 electrons. 6 electrons are lost. Okay, oxidation reaction. Now look at here, in the situation, look at here, you can see in reduction reaction 6 electrons are gained, in oxidation reaction 6 electrons are lost. Equal number of electrons are transferred. Okay, loss of electron and gain of electron is equal to 6 electron. Okay, in this case, how we can calculate N factor value? Keep in mind, we cannot apply the formula N factor is equal to N2 minus N1, because you will get 0 value, and N factor value for any substance is not 0. Anyway, it is not possible. So in this case, first of all, you have to balance the charge. You can see in this case we have 6 electrons are gained. In this case, 6 electrons are lost. So when N1 and N2 values are same, so in this case we cannot find out the difference because both values are same. So N factor value formula you will use N1 is equal to N2. Okay, N1 is equal to N2. Because we are not going to find any difference, both values are same. So N1 is also 6, N2 is also 6. That's why N factor value is either equal to 1 and N1, N2. That's why N factor value you can write it 6. N1 is also 6, N2 is also 6. Let's say if I say N1 and this is what? N2. Both values are same. So out of these two values, pick one value. Pick one value, and that is the N factors. Very simple concept. Okay, so you can see this is also decomposition reaction, and previous two examples, in those reactions also decomposition reaction, but you can see scenario is different. Okay, in this case same number of electrons lost as well as gained. Okay, in the previous examples we had the difference in oxidation numbers and difference in oxidation numbers, and it was different also. In reduction reaction we had different number of electrons, in oxidation reaction we had a different number of electrons lost. Okay, so just apply, if difference is there, apply the formula n factor is equal to n2 minus n1. If difference in oxidation number is not there, in both cases if it is same, then use the formula n factor is equal to n1 is equal to n2. Let me take some more examples. Intramolecular redox reaction is on the board. Let's write down the oxidation number of atoms on both sides of the equation. Okay, now you can see it is a polyatomic ion. It is known as ammonium ion. You can see this polyatomic ion charge is always fixed. Ammonium ion always carries plus 1 charge. Okay, plus 1 charge. Now if I calculate the oxidation number of nitrogen, so overall charge is what? Plus 1 is equal to plus 1 nitrogen plus 4 hydrogen, and hydrogen attached to non-metal always shows plus 1 oxidation number. Here we have plus 1. Nitrogen plus 4 is equal to plus 1, then nitrogen is equal to what? Plus 1 minus 4 is equal to minus 3. Nitrogen is present in minus 3 oxidation number. Okay, very simple concept. Now if you see, it is also a polyatomic ion because it is one polyatomic ion and this is another. We can crisscross numbers, so 2 will go this side and 1 will come this side. So 1 is positive and so 2 is negative. First one is positive and other one is negative. Okay, so that's why we got ammonium ion having plus 1 charge. Okay, and this is what? Cr2O7 and having minus 2 charge. Okay, we have, it is also Cr2O7 and it is minus 2, having minus 2 charge. Calculate the oxidation number of CRs, metals. 2 CRs plus 7 oxygen, each oxygen is what? Minus 2. Overall charge is what? Minus 2 is equal to minus 2. 2 Cr minus 14 is equal to minus 2. Then 2 Cr is equal to what? Minus 2 plus 14 is equal to, we got plus 12. You can cancel it, we got plus 6. Cr is equal to plus 6. Each Cr has plus 6 oxidation numbers. You can see chromium is present in plus 6 oxidation numbers. Okay, it is a neutral molecule, has a 0 oxidation numbers. We can cross these numbers. 3 will go left side positive, 2 will go right side negative. Okay, water molecule, hydrogen is always positive and oxygen is what? Minus 2. Okay, now we can compare the oxidation number. If I compare the nitrogen oxidation numbers, nitrogen, okay, nitrogen is minus 3, other side it is 0, minus 3 to 0, increase in oxidation number, and increase in oxidation number is what? Always oxidation in which loss of electron takes place. Here we got oxidation reaction. Now we find the difference in oxidation numbers. Keep in mind there are 2 nitrogen. If 1 nitrogen is minus 3, then 2 nitrogen, whole power 2 is there, 2 nitrogen will be minus 6. But 2 nitrogen we have 0. Minus 6 to 0, difference in oxidation numbers, 0 minus 6, then we get 6 electrons. Here we have 6 electrons. 6 electrons are lost because reaction is oxidation. Okay, it is an ammonium ion undergoes oxidation reaction. Now we can compare the oxidation number of chromium. Chromium is plus 6 on the left side and plus 3 on the right side. Plus 6 to plus 3. Plus 6 to plus 3. And you can see decrease in oxidation number is there. Decrease in oxidation number is always reduction reaction. It is an example of intramolecular redox reaction because one element undergoes oxidation, another element undergoes reduction reaction in the same reactant. You can see how many chromium are there. There are 2 chromium. Once chromium is plus 6, 2 chromium will be multiplied by 2 is equal to, we got plus 12. You can see 2 chromium is equal to plus 12. No? For 1 chromium is plus 6. Other side 1 Cr is plus 3, then 2 Cr multiplied by 2 is equal to, we got plus 6. Okay, now find the difference in oxidation number. When we calculate the difference in oxidation number, we always balance the number of atoms. We balanced it. Already Cr is already balanced. Find the difference in oxidation number. For 2 Cr plus 12 oxidation number. For 2 Cr plus 6 oxidation number. Plus 12 to plus 6. Difference is 12 minus 6 is equal to 6 electrons. 6 electrons are gained. Okay. So you can see gain of electron, loss of electron is same. And when these values are same, then we have to use the formula n factor is equal to n1 is equal to n2 Either you can name it is N1, let's say it is N2. The N factor value is what? N1 is equal to N2 is equal to 6. For this substance we got N factor value is 6. Very interesting concept, very simple concept. Okay, so it's very much important you should know how to calculate N factor, know how to calculate oxidation number of an element. Okay, how to balance the charge, that's the important part. As the remaining portion I think you guys can do it very easily. Let me take the last example. The next redox reaction is given on the board. Let's write down the oxidation number on both sides of the atoms. Okay, these are the single element a pure substance always has a 0 oxidation numbers. Okay, other left side 2 2 you can crisscross. First one is positive, second one is negative. Okay, we got it. Now we can compare the oxidation number of the same element. Bismuth plus 2 on the left side, other side it is 0, plus 2 to 0, decrease in oxidation number is what? Reduction reaction. Here we have reduction reaction. Okay, now we find the difference in oxidation numbers. One bismuth is plus 2, then 2 bismuth multiplied by 2 is equal to plus 4. You can balance a bismuth multiplied by 2 is equal to still it is 0. Plus 4 to 0. Okay, plus 4 to 0. So we have 4 minus 0 is equal to 4 electron. Okay, I move on to sulfur to sulfurs. Sulfur is minus 2, other side sulfur is 0, minus 2 to 0. Increase in oxidation number is what? Oxidation, in which loss of electron is taking place. Balance the charge. Okay, 1 sulfur is minus 2, 2 sulfur will be what? Multiplied by 2 is equal to minus 4. We multiply 0 by 2 is equal to 0. Okay, minus 4 to 0. Find the difference. 0 minus 4. 0 minus 4 is equal to 4. So we got 4 electrons. 4 electrons are lost, 4 electrons are gained. Same value is theirs. So in this case N factor formula will be N1 is equal to N2 is equal to 4. For this substance N factor value will be 4. So very simple concept is there. Very simple concept. Easily we can calculate the N factor values. In the next session we will discuss about calculating N factor value for disproportionate redox reaction.